There are many obstacles that can block the path to a successful software project. When you come across one, it helps to think like a seasoned hiker and follow the trail marked by blue blazes around the problem so that you can get back on course and keep moving forward. Welcome to Blue Blazes Podcast. I'm your host for the journey, Jay Tower, and I'm a partner and principal consultant at Trailhead Technology Partners. In this series, we talk with industry experts who share their best tips for avoiding the pitfalls on the path to successful software projects. My guest on this episode of Blue Blazes is Jeffrey Palermo, a software engineering leader, author, and CEO. Jeffrey's been a Microsoft MVP since 2006 and has spoken at many well-known conferences around the world, as well as written several books. He's known for coining the term onion architecture, which many of us have probably built over the years. In this episode, Jeffrey and I dig into the AI era and what it really means for the craft of building software. We discuss whether agentic development is just the next one of many shifts in our industry, or whether it's something categorically different. From there, we get into some spicier questions like whether the definition of code quality and maintainability is shifting, where architecture goes from here, and how AI is reshaping what our teams look like. If you want an honest, experienced take on where software development is headed in this crazy transitional time, you're going to want to listen to this one. Please enjoy my conversation with Jeffrey Palermo. Well, hey, Jeffrey, welcome to the podcast.
Howdy.
It's great to have you. Howdy, very appropriate response from a Texan.
There you go. Glad to be here.
It's good to have you. I know I've gotten the privilege of being on your podcast a couple of times, so happy to finally have you here on mine. We're talking about something I think that affects everyone in our industry right now, and I know is something that's very interesting to both of us, which is how in the AI era is software development changing and where is it going? So I know you've got some interesting thoughts and perspective on that. Jay here, just a quick break in the conversation to share how Trailhead can help you tackle your toughest business challenges. When you're navigating uncharted technology terrain, Trailhead creates custom software solutions that put you back on the path to success. Ready for the next step? Get started with an expert consultation at trailheadtechnology.com/offer. That's trailheadtechnology.com/offer. Now back to the conversation.
Yeah, it's interesting to reflect just back on my career, which I think we're roughly the same age, but a little bit of work before the internet revolution, and even remembering a time when computers were not connected to each other, and now every computer is connected with each other. And then the different eras of heavy project management in the 90s versus the agile transition, and then the DevOps transition, and then the cloud transition, the mobile transition, where now you can run software. You have a computer in your pocket. Just carry around a computer with you. And now we have what looks to be a massive AI transition. And of course you have the futurists and the naysayers that it's going to do everything automatically. Well, I think everybody's already seeing, okay, that's not going to happen. All right, so now it's a new technology. What is it useful for? Let's use the heck out of it and use it for what it's good for. So, one thing that I know is AI is not going to do all software engineering. It's not going to do all software architecture. It's not going to do all business analysis. I mean, there are jobs where there is not a clear answer, and then there are jobs where there is not a clear question. I think that's the most. That's what I think about a lot. The AI tools, they're really good at answering questions, even when there's not a good answer. They fake an answer, and we call it hallucination, as if there's any kind of awareness. But there's always an answer, whether it's idiocy or not. And so you use these tools to answer questions, or there's a clear task. Okay, do this. Write this code, or summarize this text, or classify this image. But AI has no capability to actually formulate a useful question. It's excellent at answering the questions and processing text, but it doesn't have any awareness to know what questions are actually worth asking. That's where the human wisdom comes in. I mean, even when the question posed isn't really a good one, the AI, the large language model personality will congratulate me on the insightful question and provide an idiotic answer to the idiotic question.
Right.
I think about the scientific method. There's a lot of study and a lot of publishing around the scientific method and how we test hypotheses and how we run experiments and have hypotheses promoted to a theory and then a law if we can't disprove it after a while. But in the scientific method, the whole process starts when someone actually generates a hypothesis. And there's actually no process in the scientific community or no agreed upon logical method for how to come up with a hypothesis. If you look at Einstein, what became the theory of relativity, how did he come up with that hypothesis? I wonder how. There is no process. There was some spark of inspiration. There was some wisdom. You could say it was some supernatural revelation. It just popped into his mind, right? How do things just pop into your mind where you have a hypothesis or you have a question to pose? And if we don't even understand how we formulate good questions, how we formulate great scientific hypotheses, how can we program it into an AI tool? So these AI tools, there's no capability to formulate that top level what if. But once we have the what if, once we have a good question, then yeah, AI is incredibly useful in the downstream research and answering process. So that's one of the things that I think about. I've got a number of others, but that I think about that a lot.
Really interesting. I love the way that you put that too. So I love you reading my mind as well. My very first question for you was going to be, is this shift to AI just like the other ones that we've seen in our careers, web, agile, mobile, cloud, etc., or is this categorically different? It sounds like you're saying it is categorically different. Would you say that?
Well, yes, it is. It is categorically different because it's not just another way to write code. It's a different way to interact with a computer. So yeah, I would say so.
Yeah. Yep. That's a good way to put it. I like how you kind of break down too, though, what AI probably, and I think we always have to say probably when we're predicting the future here, right? But probably will never do some of those things. I think you could almost say, maybe summarize what you were saying as wisdom and creativity, maybe. Those are things that AI or curiosity doesn't do, and that humans are best at. So I love your summary as well of it doesn't ask questions. That's really great because obviously when we're interacting with large language models, it's always us asking the questions.
Yeah.
So when you approach AI generated development, what are you thinking about to like in that approach, or what do you do to make sure that you're not creating AI slop, as they call it,
Yep.
but still creating genuinely good software?
So probably three things. One is the architecture of what this AI technology actually is, and the other is how to verify that something generated is good, and then what are the dynamics of all of the principles that have come before. So you mentioned wisdom. I think that's a great way to think about it. These language models, and by the way, regardless of what AI tool harness is using the language models, Codex, Claude, Copilot, Cursor, why do they all start with a C or hard C sound? Anyway,
it's like a rule.
Exactly. Except for IBM Bob. They totally IBM Bob, which like Cursor is another fork of VS Code, and then they kind of bake it in right there. Been having fun with IBM Bob lately.
Have you? Interesting.
Yeah. But these language models, there is no wisdom. There's there's not even any kind of awareness or
Mm.
understanding or actual intelligence. That's a terrible name. We call it artificial intelligence as if
Mm.
it's real intelligence. Well, no, it's maybe an aspect. I mean, that original 1956 hypothesis from John McCarthy of you know what, if we just take an element of human intelligence and we describe it so precisely, then we can make a machine to simulate it. Well, that certainly is true. We've taken the language aspect and bringing in a whole bunch of text, and guess what? We
Mm.
are we are simulating the heck out of it. So that is still true. But there's no actual intelligence.
Yeah.
There's not even any awareness of what the instructions mean. I think it's important. We need to understand what it's actually doing, so we don't expect
Mhm.
it and rely on it to do something that it's just not going to do. So
Yeah.
there's no awareness of what the instructions mean. There's no ability to know when a task is complete, and there's no really innate sense of whether the outcome is good. I know if the outcome is good, but there's so many times, like you mentioned, slop, when there's output that comes back, you look at it, you're like, this is terrible. Let me try again. If we think about the architecture of what these LLMs are, it's that probabilistic response um, of traversing through this neural network. It's guided by a
Mhm.
system prompt and user prompts and the tool results, and it's just traversing this neural network and landing on what's probably the right answer. And the better models,
Mm.
they hit close enough to the mark and often enough to be tremendously useful to us, but it's not intelligence. It's just
Yeah.
probability, uh, and so if the technology has no way to know if the response is good, then the test of if it's good has to come externally. We have
Mhm.
to provide the mechanism to judge whether we should accept this or whether nope, it's
Mhm.
not good. And the compilers, if it changes some code and then runs a tool that runs the compiler, well, there's errors that can funnel back into the context windows. So still, the definition of good is coming from the outside. It's coming from a tool call,
Yeah.
but it funnels back
Yep.
in. And then, oh, this is not good. Let me try again. And
Yeah.
so, if we can't, to the extent we can connect tools and builds and things to funnel back error messages so that, oh, it's not good, try again. Well, then we have to fill in the gaps so that we truly have a, a comprehensive external standard of, yes, that's a good
Mhm.
response. Let's take it.
Yeah. 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 I think a lot of times about, I mean, you coined onion architecture. Our friend Jimmy coined the term vertical slice architecture, right? There's all these things that have come to our industry over the years that have been different people's kind of aha moments or creativity or whatever you want to call it. That is very different from what AI does.
Mm-hmm.
And now the AI is pretty good at copying that, right? If I told Claude or something that I wanted to use onion architecture with this application and I want to use this tech stack and everything, it would mimic what it's seen.
Mm-hmm.
But it's never going to come back to me when I say that and say, actually, Jay, I think a different architecture would be better that no one else has ever
Right.
thought of before.
Right.
So, like, we still need the humans for that part.
Yep. Yep.
So you mentioned architecture too. I want to talk a little bit about that with you because I know we're both interested in that topic. And this is maybe kind of a spicy question or a heretical question, but if the code that we're generating now, largely with AI,
mm-hmm.
performs well and is secure, and the same AI can go back and read it again and edit it just as easily,
Yep.
does it matter some of the things that we've historically been calling code quality, human readability, human maintainability? Do those questions still matter?
Well, they they've never been so they matter, but I think they've always indirectly mattered. It's not
Hmm.
ever been the actual thing that matters. What matters is that a system is stable in production and useful to the users and consistently does the useful thing that people depend on
Mhm.
it doing. I mean, that's what actually matters to the business. And we've had enough time. There's enough uh, industry muscle memory and industry pain from when it goes bad that we've realized, okay, when something goes awry in production, and I look at where the bugs are, you know what? If I can't even understand with my eyeballs what this code is doing, this spaghetti code it's so disorganized, then yeah, bugs tend to hide in code that I can't even make sense of. And so then we say, okay, it's bad to have spaghetti code. It's bad to have code that I can't even make sense of. Or if we have duplication all over the place, and I fix something, and then some user finds that the same type of bug is in some other screen, I come back and say, oh yeah, the same bit of logic is over here too. Let me fix it here. Then we've learned to say, you know what? If we duplicate like whole functions at a time, then the bugs are probably going to be in multiple places. So okay, let's not repeat ourselves. Let's reduce that. And so I think it matters, because we want those stable, high quality, bug free systems in production. And you could question, well, what about the AI? The AI will just do it automatically. Well, I mean, even with 1 million token context windows, the entire system is not in the context window. It's a part of the system. And I did a quick calculation of our own brain and the amount we learn in, let's say, just not a lifetime, but even in 20 years. And the computer would have to, I think I calculated it, it would have to have the equivalent of a 1 billion token context window to equal what we keep in our own brains. I mean, we have a memory of every production issue we've been involved in, every bad thing that happened in the system, every time a build broke and surprised us. We have that memory, and when we look at something, we do that instant correlation. And I mean, that's because our context window, to make that correlation, is massive compared to this small, dinky million context window that we're currently working with.
Yeah, we got 1,000x to go here to catch up, which you could make the argument, I mean, the way things are scaling, you could make the argument that at some point we will catch up to that context window, and that maybe the computer's context window is more deterministic than ours. I don't know about you at our ages, but I sometimes forget things. I can't remember what we decided in a meeting a week ago.
Yeah. Well, that'll be interesting to see. But you asked about architecture, and does that matter? And Onion architecture is really kind of applying domain-driven design principles on top of Alistair Coburn's hexagonal architecture, which focused on just the ports and adapters, which was the interfaces to external things from the application. And I still believe that the structure of what's inside your system also matters, not just the adaptation to the outside world. But I think that I haven't seen any language model or AI tool have any kind of good reasoning around the part of architecture that has the most consequences, which is structural. If you think of a skyscraper, every office building in every floor of the skyscraper could be configured completely differently, but it has a steel structure, it has a foundation, and it has fire escapes. It has tower wide systems, regardless of what company rents space on each floor. And if we had this auto magical 3D printer that could go into an office and totally redecorate it, put in new carpet, change things around, we really wouldn't care, because oh, well, if it gets it wrong, okay, we'll just fix up that office, no big deal. It's bounded. And if we said, go ahead and configure the entire floor, move walls, totally change everything, we wouldn't care either. But it would be a problem if this automagical 3D printer in the physical world started changing where the elevator was on that floor, or the fire escapes, or the fire suppression system, plumbing pipes, because then the system that went across the full building is now broken, and the structural integrity of the building is now compromised. And so that's where the AI tools, what I think about the difference between vibe coding and actual software engineering and architecture. if you quote vibe coded, if you just you regenerated the code that was in a particular method, you walked away, you didn't even look at it, and then said, "Oh, it works," you're probably okay, right? It's just one method or even one class. But when you have patterns that are like strategic patterns, they are the structural support of the software system, and now that was just changed. That's a problem, and I don't think that we've seen any kind of awareness that some code in the system represents steel girder beams. It represents the structural support of the architecture versus other code that's just office decoration. And I don't
Yeah.
see the language models having any good differentiation between code A and code B. But we know when some code is structural in nature and when it's just window dressing.
Yeah, that's all really good points. Maybe this is just thinking about it a different way, but you made me think that it's easy to forget that these, AIs, as we call them, probably inaccurately, are actually language models. They're just language models that have learned our programming
Yeah.
language
Yeah.
patterns. But some of those patterns are sort of meta patterns, the patterns about how we organize the code. There's nearly an infinite number of ways you could use any particular programming language, but we tend to use them a set number of ways, right? So if we train these language models on that and then we do it some different way or we do it inconsistently throughout a particular application, it's probably going to make mistakes or assumptions that are incorrect about the code just because it's not following internal patterns.
Yeah.
Your example of where the walls or where the elevators are on different floors. Yeah, that makes total sense to me. Unless and until we get to the point where the AI is just directly creating compiled code with not the actual coding language to compile it, but the actual compiled code.
Yeah.
Like it matters how it's writing it, right?
Yeah. Absolutely. Absolutely.
Interesting. Great perspectives on that. I'm curious with your experience on the full software development lifecycle there at Clear Measure. A lot of people are saying that because AI speeds up the implementation phase, and this is what we're seeing at Trailhead, you now are coding a lot faster. You're getting features done a lot faster, but there's obviously other parts of that pipeline that we call the software development lifecycle: design, requirements gathering, testing, all of those things, documentation, all of those things. And some of them you can speed up a little bit with AI, and some of them not as much. The requirements gathering is a good example. That comes from humans. How are you seeing, these bottlenecks shifting from what used to be, well, it's going to take us months to code that, so we don't really need to rush requirements gathering, to all of a sudden like, oh, we got 10 times as many PRs to review, or whatever it is, the different bottlenecks that you're seeing in the process now.
Right. Right. Well, I think that everybody would do well just to look back on the last probably 50 years of research and learning and publication about flow-based systems. And basically our software development lifecycle is a flow-based system, and look at all of those learnings and what has stood the test of time, because no technology has ever completely invalidated what was a good idea before. I mean, even the railroads, it didn't invalidate the fact that we need to know what is on the train. We need to know what is being transported, and that people being transported is infinitely more important than a box or a crate being transported. I mean, there's some ways of thinking about things that just because we have a brand new invention doesn't change it. And I think back to, and I reference a few books all the time. Going back to 1984, Eliyahu Goldratt book, The Goal. That book taught us the theory of constraints. I mean, that book is part of the curriculum of MBA programs. And then the Toyota Production System by Taiichi Ohno. That was right around 1978 or 88, somewhere in that time frame. And that really taught us the elimination of waste and the profound effect that can have. And so I think that those principles are still guiding us today. But specifically to answer your question, what AI changes in that process is that, yes, we can generate a lot more code. We can generate a lot more changes way more frequently and faster than we ever have been able to before. And so it has the promise to change the bottleneck where our business partners is always asking, is it done yet? Is it done yet? Are we going to meet the deadline? We really want to go live with a certain customer on this date. Is it going to happen? Where it's constantly waiting on technology, waiting on software engineering. And in order to move that bottleneck, we need to have our verification of, is it good, to keep up with the faster inner cycle time of AI driven development. And I mentioned that the definition of good has to come from the outside. And so if our methods of validating good is the way that we did testing and builds for the DevOps and cloud era, which is way better than it was, previous eras. We think we're going fast, and the 10-minute build and automated deployment and all that stuff, and we can deploy in the middle of the day. That's fantastic, but it's too slow for AI-driven development. Because if we keep doing builds and deployments the way that was great for DevOps and cloud, then we're not going to get the benefit of AI-driven development. We're just going to have pull requests that stack up, or we're going to miss things, and we're going to be generating a whole lot more bugs that hopefully we catch. And so the build and test speed has to speed up to match the new AI-driven development change rate. The validation pipelines have to be faster than in the previous era. And overall, changes can only move as fast as our ability to validate them. And ultimately, every time code is changed, we need to have a good answer to the question, do I still have a stable code base? We have to really know the answer to that question. And if we push validation downstream, well, it just creates a growing work in process inventory for some stage downstream. So the theory of constraints, flow-based systems, and the quality dynamics, those don't change. And most teams aren't going as fast as they could be because they're not actually working on new features for all of their work week. They're stopping the work on new features and they're fixing bugs. They're doing rework. They're getting issues escalated from production as second level issues that they're dealing with. If they were truthful about analyzing that pie chart of where they spend their time on, they would see disturbing slices of the pie where they realize, oh shoot, are we really only spending like 20 to 25% of our work week actually working on the new release?
Yeah, which seems to be true, right? When we've sped up that 20%, but the other 80%, we got to figure out how to speed that up too. How do you see that applying to DevOps? So I've seen, for example, I've seen some talk recently about maybe we need to do more builds locally on developer boxes as a way to kind of shift those constraints. The shift left that we've been talking about for years in DevOps. What other ideas or technologies have you seen that are helping speed that up?
Yeah. Well, every single behavior of the system has to have an automated test. And then we have to we have to know that test is still green, is still valid all the time. So before we turn AI loose on changing our code, I would make changes that would accidentally break a test, and I was okay, missed that, and then fix it. It was a great safety net. And now we have the AI tools making changes, and I will submit that when you're truly implementing something, you do have to review everything that the AI tool is changing. And some people are going to say, I'm not going to read every line of code. And if the line of code represents hanging the drapes on the wall, whatever. Your review can be super fast, super cursory, because it doesn't matter. But other types of code, you probably need to read every line, read every character, and you need to decide more important code versus less important code. What I'm saying is, you need to know what is being changed. All right. It's not okay. When you are in business critical software systems, this vibe coding attitude of, oh yeah, change something and, well, it looks like it worked, so ship it. Well, then why even submit a pull request? If you're not going to review the changes in the pull request that you created, why are you even submitting it for somebody else to review? What's the point?
Right.
Obviously, I'm being sarcastic, but I'm saying if it's important, you actually need to know what is being changed, and you have to make the decision in your head, is that what I want? Because ultimately, my name is going to be on the git commit. My name is going to be on the pull request. And I can either be a professional or I can be short-lived at that company. If I turn in shoddy work. But the builds, the builds have to be faster. The automated tests have to be comprehensive. And this is one thing. In order for it to do that, we have to move away from 10-minute builds. We have to get down to 1 and 2 minute builds. And computing is cheap and pervasive. And so I think that the mentality of creating a build script where you do a compilation, you run unit tests, you build up your test database, then you run integration tests, and then you run full system acceptance tests, and then we package for deployment, and those are sequential, and let's keep it under 10 minutes. I think that is no longer sufficient, and we have to parallelize all these steps so that we can still do the same level of validation, but figure out how to get it down to 2 minutes. In other words, these unit tests, parallelize every one of them, run it on machines with more processors. The integration tests, we can't clear out database tables. We have to make our tests resilient to working on a test database that has other records in it, and packaging. Once we don't have to package for deployment after everything succeeds. Once we compile do a .NET build, once we do our compilation, we can start packaging in parallel, even while tests are running in parallel. Because, well, if something fails, I just throw it away. No harm, no foul. But if I wait, well, now, so you want to absolutely parallelize every single step that you can to get that build to run in as short a time as possible, because we need that build to be running all the time, everywhere, local on the engineer's workstation, on the build servers, on every single branch. We need to know in as soon as we can, okay, some change was made. Do I still have a stable system?
Yeah, great feedback. I'm also curious on the topic of teams and how AI is causing those to shift. Something we've noticed here at Trailhead is that, in a way, you can consider an individual plus their AI or AI agents as almost like a little team. The way they can get things done together, working together, as directed by the human, hopefully. How do you see that sort of thing shifting how the humans work together? So what used to be maybe 4 or 5 people working together on a team could maybe be done by 1 or 2 people working with their AIs now. Does that mean we end up with smaller teams? How do we still handle some of the places where we interface with other people, assigning different work tasks to different people, merging pull requests, code reviews, all of those types of things in this environment?
Yeah. Well, it's a machine. It's a tool. I mean, I think this is one of the concepts where we'll grow out of it. I mean, we're only a year into this era, and we call it the AI, and some of the tools are encouraging us to give them names and call them an AI team member. That just doesn't make sense to me. And then because that language has crept in, Well, now we say, oh, the human developer. Well, what other type is there? I mean, this farce that there's an AI developer. No, it's still a machine. I mean, we call ourselves human beings, but I think that the important part is that we're a being. This computer technology is not a being. I mean, even in the military and in the police, a canine unit has a fairly intelligent dog for what the dog can do, and that 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 person and the dog, they end up being a unit because equipped with the dog. Which, I mean, some of these dogs, you look at what they can do and they're amazing, right? Equipped with the dog, well, now this person can do more, but the dog is not the person, right? And so with a tractor, with a big old combine, you can send a 12-year-old farmer's son out into the field to operate that big old machine and get a lot done. And so equipped with the amazing machine, well, now this person can be a lot more effective, but it's still because we're equipping the person. The machine is not the thing. The machine is what we equip the person with. So that's how I think about it. And every time someone says, oh, it's an AI team, it's like, no, you just have a lot of machines working for you, just like the loom. You can make blankets or things if you have a great loom. So yeah, I can be more effective when I have amazing tools, amazing equipment, amazing machines that I can operate. But for the last multiple decades of computing, we've had software systems where a person, a user, clicked a button, typed in some things, navigated, and did something with the software. And you knew who was the operator, that person who clicked the button on the screen. But then the system also has batch jobs that just kind of run on a schedule, run on a trigger. And none of the typical business users were operators of the batch job. So who was the operator of the batch job? Well, it was the person who was on call for production, right? There was still, it's like, if that batch job failed, didn't run, by golly, we knew who was responsible for jumping in, fixing it, and get that batch job going again. Because machines have to have an operator. Right. This type of machine, the AI tools, even automated AI agents, they still have to have an operator. And they have to have a skilled operator. I think that's important. The skill and the capabilities of the person who is operating these AI tools, that's what it's all about. Because you're going to get a whole lot more output, a whole lot more good progress from someone who's highly skilled and wise than someone who's not.
Yeah, that makes sense. Even as these skilled operators, if you don't think about them as like running a team, if you don't think of the AI as a team, it's just the tools that's making that person more productive. If their output is like that of a team in the past, let's say, each individual can output something similar to what a small team could do maybe in the past.
Yes.
How do you see that impacting the collaboration? This may be a similar question to what I asked before about bottlenecks, but all of a sudden you've got so much work coming out of one individual, and they have to merge that. They have to communicate with the other humans that are also working on maybe similar or adjacent features or that sort of thing. How do you see that working?
Well, we've seen this before too. And that was in when extreme programming was really dominating the early agile scene before Scrum kind of took over the training aspect. The practices of extreme programming was the early agile adoption, and that gave us continuous integration and all of the technical practices that underlied it. I mean, that was that bundle of extreme programming practices. And we saw, and I have distinct memory of this, where the industry's muscle memory for significant software projects was to get 20 to 30 or 50 or 100 software developers on really big software projects and split them up into pot and have everybody going. And what the extreme programming practices in the agile movement gave us was shrinking those teams. And I remember one project where the uh, the product management and the end users were getting new builds of the software system so quickly and so many new functions that it was shift left. That became the bottleneck. And so the team had to be downsized all the way down to 6 software developers just to slow the pace of the project to what the analysts and project managers and then the subject matter experts that were analyzing and validating everything, and also having debates of, oh, should we have it work like this way or should we have it work that way? I mean, that just needed time. And so we've seen that before. I think it's happening again. It's happening again in a profound way. And I think that Fred Brooks's surgical team is now coming back to fruition. So we've come full circle. So Fred Brooks is famous for the Mythical Man Month essay, which I think a lot of computer science programs in university have as mandatory reading. But that's just one of the essays in his book with the same name, Mythical Man Month. Another one of the essays is the surgical team. And he posits that an ideal software team is like a surgery room in a hospital where you have a chief surgeon and you have an assistant surgeon. And that's the number of hands that can go in the patient. There's not room for any more. And then you have nurses, you have a hospital record keeper, you have other assistants that are in the room that are in the periphery assisting, making sure that the chief surgeon and the assistant surgeon are completely undistracted and focus on the patient. And that's 2. And in the mainframe software days, that was the context of the original essay. And then, of course, the mini computer and the internet connected software, we could do more and more software. So we would throw, dozens of developers at a problem. And then we went searching the world for the cheapest developers per hour. And now it's coming back with the AI tools. I mean, when's the last time you had to do a Google search to find an answer, or oh, God bless Stack Overflow. I mean, that fewer and fewer people are searching, because all the time spent trying to figure out the answer, all the time spent trying to get a particular library or API just to figure out, how does this work? All that time, poof, gone. It just doesn't exist, because now we have those answers pretty automatically. And so now I think we're getting back to an ideal team of 2 and maybe 3, but an ideal team of 2 for still a pretty significant software system. Now, in the enterprise, if you have these massive projects, okay, you have multiple things, but for any one thing, a pair. Now, you can go all the way down to 1. Technically, yeah, you can go all the way down to 1, but it is not good for man to be alone. It's a person, always good to have a partner, someone to work with. Yeah. So a pair, and man, a pair of really capable software engineers can get a lot done, and in a lot of cases outpace the customer's ability to ask for things and answer questions when there's choices posed.
Yeah, that's been our experience, is that we already had kind of surgically sized teams here at Trailhead. Guessing you probably did too. And that some of those surgical teams were able to work faster than, clients 20 or 30 or larger size teams, just because they're used to working that way. And now even faster, because AI is doing a lot of the typing for them.
Yeah, absolutely.
So I'm curious, I know you do custom development at Clear Measure, just like we do. And I'm wondering how much you're seeing a shift in the buy versus build math. It used to be that custom software was always the most expensive option, as anything with the word custom in it would tend to be. And now, I see numbers a lot of times like 2 times as fast over a large number of tasks. Does that change the math for clients? And if so, are they doing more work? Are they just doing the same amount of work but at half the time? What are you seeing?
Well, I think it's early, but I'm already seeing a few situations that probably it'll become a trend, but it's it's just the realization that some type of project that maybe I'd been delaying because the price tag on that type of project was too high. Well, now the price tag on that project is a lot lower, so maybe I will do it. And it's too early to actually measure, but I'm seeing a few things where my gut tells me that we have entered into just the beginnings of a custom software boom cycle, where because so many projects, the price tag is so much lower, now businesses are saying, okay, well, now it makes sense for me to do it, so now I will. So now there's a whole lot more software projects being commissioned. So rather than AI, some doomsayers, putting programmers out of work, I actually think that we're going to see a spike in the number of programmers needed. But no, that's the wrong word. We don't need people who are merely programmers. The previous era needed to fill out teams of programmers. Now we need true software engineers. And I think the big difference is coming to bear, where in engineering, you're faced with a problem that's pretty ambiguous. There's not an obvious answer, or maybe there's multiple answers, and you have to go through the process to figure out what the best answer might be and put it in place. And then you can do the programming. So I think that we're still, as an industry, we're still in a shortage of software engineers, and we need those.
Interesting. I'm sure a lot of our younger audience will be happy to hear that if they are in the computer science space, if they've gotten a degree recently or something like that, they'll be happy to hear that. I tend to think something similar. We at Trailhead, we rank a lot of projects or features that clients want to work on kind of a two-dimensional matrix. With the first one being how valuable is this? Is it going to really change things? Is it going to save a ton of money or make a ton of money for the company? And then on the other matrix, or the other axis of the matrix, it's how much effort is it going to be? And we've got a lot of things that are on clients' backlogs that are high value, high effort, and they say, yeah, that would be valuable, but it's just not worth that much effort to do it. And all of a sudden it's high effort, it's high value, medium effort, and all of a sudden, like, that's worth looking at again.
Yeah, for sure.
So I think we've got time for one last question. You kind of already answered my question. I wanted to ask you about what would you tell a 22-year-old that's considering a career in software? I mean, you hinted at that, so I'm going to skip that one and just say, paint me a picture. 10 years from now, look in your crystal ball. What does software development look like in your mind?
I think it looks vertically integrated. I think the notion of a IT department that has this army of software developers that will have had a 30-year run and will be over, and we'll get back to how we operated computing business machines before, I would say, before the networking, before widespread networking, where you had a business division that had some computers, and you had the computer operators and computer programmers in that division, not as a separate department, not as a separate IT department. I think the concept of a separate IT department is going by the wayside, and every group and team that does something useful in a business will also build or buy and integrate whatever computing tools, whatever custom software is necessary for that team, for that department, and we'll decentralize once again.
Interesting. That's not the answer I expected, so that's an interesting one. And you're on the record now, so 10 years from now,
Sure.
if podcasts still exist, we can meet up and see if you were right. Okay, final question I ask every guest on the podcast. You and I have been talking about the future of development in the AI era. and how that affects creating custom software. I'm curious what other topics related to predictable quality in our software or guests you would recommend that we have on the podcast.
So, as a guest, I would recommend Capers Jones. And he is probably the most prolific publisher of software engineering research and metrics that I'm aware of. If you just look at Capers Jones and software engineering or applied metrics, I mean, I don't know how many books he has published now. But there's a theme. There's a theme that his work really helps us to focus on, and that is the question: what do I have? I've got some software, but what do I have? How do I take an inventory of what I actually have? How much software do I have? And how much is it worth? I know how much it cost to build. A lot of his metrics are in the characterization of function points, which is an old methodology of quantifying software, but it's still the only economically objective method that we have, even though very few people are trained on it. And when estimating, it's still the only economically defensible way to estimate a software project before you've built it. You can't use story points, because story points is just a unit of change. If you change something and then change it back and then change it back and then change it back and then change it back, well, your story points keep on going up, right? But if you think about, well, what do I have now?
Yeah.
And so it really quantifies your architecture, the how much you store internally, how much you integrate with on the outside, how many incoming integrations, how many outgoing integrations, how many queries. And so it's a very useful way to inventory the architecture of a system so that you can say, well, how much software is here? Because lines of code, that's all over the place, just depending on how you put it together. So I think that would be a fantastic future guest and future topic.
That's a great suggestion. I love it. I want to thank you for sharing your human wisdom and creativity with us today in the podcast. You've been so much better than an AI guest could have ever been. So appreciate your time today, Jeffrey.
All right. Yeah, happy to be here. Thanks.
That's the end of This Blue Blazes podcast. If you're interested in hearing more conversations like this one with industry experts focused on how to make software projects more predictably successful, make sure to subscribe. Trailhead can be found online at trailheadtechnology.com, on Twitter, LinkedIn, and Facebook. Until next time, thanks for listening.